So, if we want to now look, we want to, yes, ma'am.
The last problem that we did, I have to get rid of the 3 to the bottom 3.
Oh, okay. Let's redo that. So we're starting out with 9 moles of potassium hydroxide, and we know that we want to have as our units in chemical, the next box, moles of potassium hydroxide. We know that we want to end up in potassium phosphate, so, and we want to end up in moles of potassium phosphate. The numbers that we're going to get there are our mole ratio. That's our mole ratio. So all we're looking for is the coefficients from the balanced chemical equation. So 3 moles potassium hydroxide. Every 3 moles of potassium hydroxide will give us 1 mole of potassium phosphate. Now you know what? Here's a good note and a good caution. Remember how I said you're building a ladder? You're standing on the rungs you've already built. What happens if your formula is wrong? Well, then your coefficients are wrong. If your coefficients are wrong, your mole ratios are wrong. So it's this whole big snowball effect. You have to write good formulas, and you have to balance it. And most of you, once you've got the formulas, you're fine with balancing equations. I don't see any problems with that. But some of you still have some little missteps on formula writing, so you got to make sure you're really good at formula writing. Okay, other questions on that? That was a good question. Okay, molar mass. So now we want to think about how many grams of something can we produce? Or if we're given this many grams, how many moles can we produce? So we've got that same equation. 3 moles potassium hydroxide, 1 mole of phosphoric acid yields 1 mole of potassium phosphate and 3 moles of water. So we said we took 9 moles of potassium hydroxide. I'm going to write this down below here because this is going to be a long one. 9 moles potassium hydroxide. We set up a factor label that helped us figure out. So we've got moles of potassium hydroxide, moles of potassium phosphate. So we got as far as figuring out how many moles of potassium phosphate we could produce. Well, who cares? If I hand you a chunk of something and I say, here's 3 moles of aluminum, you're going to look at me like I'm a lunatic, more than you already do. We really, in the end, we always want to know the mass of something, because that's the terms our brains work in. So we set that up, and that got us, we put in our mole ratios, which we got from where? Where did we get those mole ratios? Coefficients. So 3 moles to 1 mole. Well, now we want to know how many grams of potassium phosphate are we going to get. What do we have to do? We have to figure out molar mass. Calculators. 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 In the periodic table. So we've got, and if your formula is wrong, guess what? Your molar mass is wrong. Are you starting to go, oh yeah, oh boy, oy vey, weeks. I'm going to make sure my formulas are right. Yeah, and your formula is the foundation for everything else you're going to do. Ever in life. Well, okay, not ever in life, but ever in chemistry. So we've got 3 potassiums, 39.1 times 3. We've got 1 phosphorus, 31.97. I'm sorry, 30.97. And we've got 4 oxygens, 4 times 16.00. So 212.27. Okay, so the math is right in the slide. I just like to double check. So now, if we want to end up in grams of potassium phosphate, What units and what chemical do we have to have down here? Somebody wearing a scarf. We got 2 today.
Say with moles
Yeah. What units, what chemical? Moles of what? Yep. So we want moles of potassium phosphate, K3PO4. Now, the units we want to end up in, grams of KPO4. Is there a relationship between moles of KPO4 and grams of KPO4? Why, yes, there is. How convenient. So, if we have 1 mole of K3PO4, we know we have 212.27 grams of the stuff. Worst handwriting ever. My apologies. Okay, so we're pulling those numbers straight from the equation and the periodic table. And we get 636.81 grams of the stuff, and we can actually keep all those sig figs. So remember, we're basing our sig figs on our molar mass, not on 1 mole. Yes, ma'am?
Do you always write 1 under the grams, or do you write the same number as?
No, that's a good question. So, where is that number coming from? That is a molar mass ratio. So, for every box in a factor label, so this is a box, this is a box, remember that the top has to be equal to the bottom in some way. What we're saying is that in 1 mole of potassium phosphate, there are 212.27 grams of potassium phosphate. If we used a mole ratio from there, we would be making an untrue statement. So this is just saying that this is equal to this. And what this is saying is that in the context of this equation, this will yield this, or this will yield this. That those two things are equal if we run that reaction through. Okay? It'll get clearer, I think, as we practice. Does that help? You don't know anything?
I don't know if you always use a 1.
When you're doing molar mass, yes, you always use a 1.
So you don't change the number?
No. When you're doing molar mass, you're always going to be saying this many grams is in 1 mole of this stuff. Okay, other questions on that? Okay. Ha, 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 ha. There we go. Okay, so we'll do some more practice with mass to mass. Actually, let's stop here and let's do that practice.